So right now I'm on conditionals. I'm going to scroll back up. So we have switch statements. We will talk about those in a second. I've been talking about if statements, so I just wanted to go through this really quickly. Right here we have the first if challenge. What would the following code display? We just did this in the function that we were just doing. We have the if statement, the else if, and the else. So we have our, if the first statement is true, then something will happen. Else, if that first statement is false, the else will execute. So what is going to be the output? Yeah. Hopefully it lets me just put A and it doesn't want me to put quotes. Thank you. Yes. So if true, this is true. 2 is greater than 1, unless mathematics completely collapsed overnight. So the console log will be A. This is, see, I personally find conditionals way more simple than functions, so I'm confused as to why they're farther along, but they're pretty easy to understand once you conceptualize. It's just a question. You're just simply asking a question. So we're saying if 2 is greater than 1 and 5 is less than or equal to 3, console log C, else console log D. So it'll be D because we're asking the computer, is 2 greater than 1? Yes, but we have the AND operator in there. Yeah, so because we have that, if this was OR, if this was the OR, this would evaluate to true because either side can be true. Because this is AND, both sides need to be true. You would see this again for if you were like validating a user. If the user's username is correct and the user's password is correct, then log them in. That's where you would see the AND operator, is when you want those two conditions to always be true. Here we see the OR operator. So this is not true. I can just tell just by looking at that immediately. But number is an integer. I'm pretty sure we went over integers. So I think I know what that one will evaluate to. Else if 6 is greater than or equal to math.floor, or to the floor on 5.8. Console log F. Else, console log G. E, F, or G? G. I like G. Correct. This one is tricky right here. Because like I said, when you see math, it's in one of these methods, it's easy to just kind of, brisk over it and think, oh, it's just rounding it. Like math.floor is just rounding it. Math.ceil is just rounding it. But it's important to remember and try to make that distinction that floor brings it down to the floor and ceil brings it up to the ceiling. So this it looks like it would be true, right? It kind of has that look about it where it's like, oh yeah, like 5.8 rounded up, that's true. But 7 with modulus 2 does not leave a remainder of 0 because obviously 7 is odd, 2 is even. There's no possible way that could evenly divide. And we went over integers yesterday. 3.4 is not an integer because integers are whole numbers. So 3.4 cannot be an integer. That cannot be true. So regardless of this OR operator, this still both evaluate to false. This evaluates to false. So our final condition, everything has failed. We have nothing else to evaluate. We just give it the final end condition, which ended up being correct because everything was false. I'm sure this talks about exactly what I just said. So switch statements are a little less common. You will use them in this curriculum. They're much more important in React. These are, like in vanilla JavaScript, you might not use these as much, but in React, they're used a lot. So they're good to know. If you like the style of switch statements, like by all means, go ahead and use them. I personally don't necessarily like them, but if you like them, by all means. They're pretty darn similar to if statements. I'd say that the case would be with something like this. If you're anticipating a lot of if else's, that might be time to do a switch statement. And so switch, we have a variable up here, type of pet, and it equals a function that is going to, I'm expecting output, please name an animal, right? Hopefully they explain this, or maybe it's somewhere. Not going to waste time on that, but in case people are not necessarily understanding what's going on here, this is calling a function right here. So it's saying this is please name an animal. So we're saying whatever the user ends up inputting, if they put in a dog, then we'll console log the type of pet from our switch statement plus goes woof. So if the person input dog, pardon me, apple. If somebody put dog in here, it would say, okay, type of pet is equal to dog. So in the switch state, sorry, I think I know what a dog is, thank you. I hate this, and there's no way to turn it off. I need a mouse, but then there's no room for a mouse. I don't know. Gotta suffer. Oh well. So you can kind of see what they're getting at here. We're going to take this variable, we're going to evaluate the value of that variable, and we're going to list the conditionals, the if statements essentially. If type of pet equals dog, console log type of pet goes woof, right? Very, very similar. If type of pet equals dog, console log.
Space in there after the parentheses.
Yep. Yeah, I personally like template strings a lot more for that reason. Concatenation kind of gets cumbersome, so I would prefer to do string literals. I thought that was Ripple, sorry. So I would probably do something with the backticks where I would go, type of pet goes woof. I'd probably do that instead, which is perfectly valid. Because concatenation is fine, but it's one of those things like if statements, like if you're starting to write a lot of them, it might be time to start reevaluating how you're writing your code. Here it's fine because it's only one concatenation. Like you're not saving much time by using a template string. But if this was like the type of pet with the breed, with the sound they make, all these things.
Like those programs that write a kid's book, you got to fill out this form and then it generates the little book.
Yeah, I bet you that would be done with all template strings, right? It would be so much easier to do it that way. So, yeah, that little sidebar off. This is how you would write a switch statement. This is a variable. Whatever the value of the variable is, run this functionality. The only thing is right here, you need a break statement. This is kind of like a leftover artifact from CLand. This is the semicolon for CLand to know that this statement is done. So when you're using switch statements, you need to make sure that you include breaks after every single case, so that way the compiler knows that that statement is finished. Otherwise, I don't recall if it breaks off the bat, if there's no break statement. I believe it just goes on and evaluates the next statement, however. So if there is no break statement, it will say, is it mouse? And if it is mouse, then it will console log that, but then it won't break, and then it will say, is this fox? And then it'll keep going down, and then it will hit the default. But since there's a break here, then it would stop there. So that's kind of like the caveat with switch statements is it shortens if statements, but you have to write break after every single one of them.
So we're at default saying if it's none of those animals and they put in something else, it's always going to go to the default.
That's else right there, exactly. So this is else, this is if. Else, if. Everything in here is else if statements, right? So if type of pet is dog, console log. Else if type of pet is cat, meow. Else if it's a bird, it goes tweet. Else if it's a mouse, squeaks. Else if it's a fox, ring a ding, meme town. Else, we're finally not passing that else if, right? We're doing else, the default. Notice how we're not putting in a case. This is what signifies that we're expecting this to be the end of possible conditions that will be passed into here. And that this is where you would typically have something right like this. This would be where you're catching an error or you're anticipating somebody trying to futz your program. This is kind of like an edge case. You're accounting for that edge case where somebody puts in like zebra. So if somebody puts in zebra, it evaluates all of these. It hits the else statement, and it's like none of these were true. So sorry, I don't know what noise that animal makes because none of those other statements evaluated the true. Does that make sense to everybody?
Having flashbacks to the original DOS games.
Yeah.
You're at a fork in the road. You're doing
Yeah. Yeah. Technology's come a long way. Looking at some of those old DOS games and stuff is insane. Comparing them to the stuff.
It makes sense what they were doing, what their life was when they put that together.
Yeah.
Just keep stringing those events one after another.
Yeah. It's really cool. I like looking at stuff like that when I'm ready for it, because sometimes it gets really meaty. So I kind of answered this earlier, but if we have this is pseudocode, right? This is English. This isn't JavaScript. If we had conditions like this, what would we want to use in this instance? Would we want to use an if statement? Do you think we should use a switch statement, or should we use neither? If the user's name is longer than 2 characters and the user's name does not contain the word admin, then then create user. Any ideas? Yeah. And the reason that is because we have this and here, and it's very short. This is a very short and concise if, else if, else. It's written oddly, but we do want to use an if statement here. Let's read this. Because you have to check multiple expressions, such as the user's age, whether they have permission, you should use an if statement. You have a combination of cases that cannot easily be reduced to a single expression with many results. So that's one thing that switch statements kind of lack is we're expecting evaluations here. We're expecting it to be dog. We're expecting type of pet to be cat. We're not setting an if statement where we're saying if this is true. If I say, if this is an integer, then console log it's an integer. You can't come down to a switch statement and say case if this is an integer, then you would have to do something where you're storing some sort of like comparison functions, something along those lines, very convoluted that we're not going to get into. In order to evaluate that. So switches are kind of limited in that sense where you have to literally write what you're expecting the input to be, whereas if-else statements are a little more verbose because these can be variables, don't forget. In an if statement, these can be variables. So this could easily be something like if you're checking somebody's age, if they're legal enough to drink, right? You could say, I keep opening GitHub. You could say if I'm just going to put numbers. If 18 is greater than 21, allow the person in, or whatever, right? So like, instead of having this here, we could have user age, right? So if now I don't have to write a switch statement if it's 1, if it's 2, if it's 3, if it's 4. That's kind of where switch statements start to lack in functionality. This is where an if statement would be far more superior because we don't have to write 1 all the way up to 18. We can just say if anything is below 21, then we can allow the person, well, I mean, it should be the other way around, right? Yeah, no, it was the right way. There we go. allow the person in. A switch statement, again, would be so many more lines of code. So just keep that in mind when you're approaching a problem, and try to think if you need to use a switch statement or not. All right. How about this one? So this is a, yeah. Yes, and so we have these very basic conditionals. I think that we would be able to check that in these switch statements. Yeah. Because you're checking one expression, the user's age, but there are many more than 3 values. A switch statement is more appropriate here. So we're only checking the age. So we still could do that essentially here. But the thing to take away from here is this is doing the same thing, right? We're saying if the user's age is under 21 or over 21, allow them in, right? But what this is doing, and I want to draw attention to this, is this has specific conditions for in between those age brackets. So here, if they're under 13, then they cannot sign up. If they're over 13 but under 16, then they can sign up but not drive a car. So because we have these unique situations that are dependent upon these two different integers being greater than each other, this is when we would want to use a switch statement, because the if and else if statements would become very, very long and verbose and kind of cumbersome. You can do it with if statements, but in this instance you would want to use a switch statement, yes.
So could you use that type of approach if you're doing like levels of membership on a website? If at this level they get access to these things, but if at this higher level they get more access.
Yeah, that would probably be stored in a table, and you would have specific, like, your team would probably decide if you wanted to store the membership as like an integer or something like that. So like, you know, if they just sign up, then you could have a table row that's like, this is the user's membership level, and you can have it be 1 if they just sign up. So then you can have it so if they purchase the next tier of membership, then it becomes a 2. It really comes down to how you want to design it, and that's why we're sometimes called software engineers, because you're the one engineering the way it's going to operate and work from start to finish. So if you wanted to have a tiered membership system, you would probably have that stored in your database in some way, and then you would have some sort of system that you would keep track of, that you would have, like, you know, maybe you, instead of having an integer that increments, you would have 3 separate columns, and that would just be Boolean. So it's like user is premium, true. User is not premium is false. User is like super duper premium, false. You know, it really depends on how you want to format your data in that instance. Does that answer the question? Yeah, okay, cool. Loops, we're running a little low on time, but loops they're complicated and they're easy at the same time. This looks like a lot of code for something that is really simple. Why are they showing while loops? Don't use while loops. You can, but the potential of breaking your browser is very high because of this right here, infinite looping. While loops are essentially, how do I say this? They are dangerous. You can easily crash your browser using while loops. I'm just going to close this because I keep thinking this is REPL. If I did, I'm going to crash my browser. Actually, I should probably open a new window. Hopefully it doesn't crash both windows. And it should warn me. It should warn me that I'm about to crash the browser. While true, console.log, destroy everything. Ugh. It's working.
Oh, that's kind of like the card effect. When you get on the system, like you just hold the key down and it makes the card effect, like 52 solids.
I Sorry, I don't have any reference to that. I was actually expecting us to crash.
It's not stopping.
It's not stopping. That's awesome. That's because I didn't give it enough to do. So what we're going to do is we're going to do another one. I'm going to try and crash this. Oh, that's C#. Cool. I guess they fixed that. It used to be if you typed in a while loop that didn't have an exit condition, it would literally crash your entire browser in REPL. So that's awesome. Maybe I can crash it in the console though. While true, oops. Console. Maybe it shouldn't be a console log. Maybe it should be a mathematical operation. Here we go. So shift enter var array of numbers equals an empty array while true. I need one more variable. Gosh darn it. Var I equals 0 while true. Come down. I plus plus. Have you guys seen that? No, because we haven't gone over loops yet. I will show you in just one moment. I really want to crash my browser. As stupid as that is. Array of nums dot push I, not index database I. Crash. Oh. Okay, well, we got a console error. What just happened? Oh, so I have my debugger on. It caught it. Oh, it might be because I'm on Red Bull. Looks like since the last time we did this, they've added some safeguards, so that's awesome. Because this used to literally crash your entire computer. Sorry, your browser, not your computer. Array of nums dot push I. Oh, I didn't declare I. All right, last try, and then I'll show you guys how to do a correct loop. Yeah, so my browser is catching on to the fact that I am trying to write an infinite loop, and it keeps catching it using the debugger. If you go over here, let me see. There is a debugger somewhere, and it's probably somewhere on your more tools. Anyway. Not going to get into that right now. We have only a couple more minutes, but your debugger essentially allows you to create breakpoints in your code so that you can look at your code at different points in its execution. There we go. So it did end up crashing. Really long-winded way to show that example, but I just wanted to try and show you guys the dangers of not writing an exit condition in a while loop. So you always want there to be some sort of way for there to have some sort of condition where it will eventually evaluate to false. So while loops are really not that great, honestly, because they're dangerous. I don't see these a lot unless people, you see them with people writing important code where they know exactly what they're doing, but I really don't think anybody should be using while loops unless the curriculum says to, because of the potential of crashing your browser. Um, it's a pain in the butt, and if your browser crashes, it has the potential to erase the cache as well. So if you were like working on the curriculum and you accidentally wrote an infinite loop and it crashed, all of your work might be erased as well. So just be mindful of that. There's two different loops. There's a do while loop. I mean, it's essentially a do while this is true. Um, they touch that on the curriculum, but essentially all you need to know is there's a while loop and there's a for loop. So a for loop is what you're going to be using far more often, and this is what it looks like. For tester is an array 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And we do console.log I. And then we'll do I console.log R. So I will explain everything that is going on right here in just one moment. Okay. I'm going to move this up. I did that by holding Alt. Whatever line you're on, you hold Alt, and then you use your arrow keys up and down. It moves whatever line you're on to whichever direction you push. So we're going to start off with the while loop. So this is what a while loop looks like. We have just a single condition, just like an if statement, right? We're asking, is this true? So the way a while loop works is, if this is true, it's going to execute the code block. This code block right here. So the danger of this, again, to reiterate, is if you don't properly write the exit condition in a while loop, it will infinitely loop and it will crash your browser. So here, one thing that you need to make sure you're doing is I'm saying while I is less than 10, see, I almost did it right there. That would have caused an infinite loop, because while I is greater than 10, well, that probably wouldn't have ran to begin with, actually, but you see the point. I almost messed that up, and that would have been a problem. So here I'm saying I'm going to console log I, and then I want to console log the array at whatever index I currently is. So I should actually probably move this to here just to match with the indices of the array, right? So we start at 0. This is the 0 index of the array, the first one, the second one, the third one, right? So now when I run this, we should see 10 console logs, of course, because I declared it in the actual loop below. So I can get rid of this for the example later. R is not defined because it's tester. So the reason I'm getting all these errors is because I just copied these over from here, but I'm just making it so it works for now, and I'll explain it. There we go. Okay, so what the while loop did is it evaluated the statement. It said, is 0 less than 10? That's true. So it's true, we enter the code block. We console log I, which is 0. 0 is less than 10. And then here, I console log array at I. 0, index. I'm realizing now that was a bad idea. Probably should have kept it something else. Maybe I'll do A. I'll do characters. That'll be strings. Anyway. All you need to know is this is actually the 0 right here. So we have I, which is 0, And then I'm also console logging the 0 index in the array. So that's why we're seeing a second 0. And so on and so forth, right? So once this finishes, this I++ is shorthand for incrementing upward once. It's the same way with decrementing, and you can have loops that actually go the opposite way. There's no distinction. It's not like one is called a positive loop and the other one's called a negative loop. They're still just called loops. It's just whatever direction you want the operation to occur. If you wanted to decrement, you could do I minus minus, and then if you wanted this to be 10, you could say this is 10, flip it, pardon me, flip this, and then just have this be 0. This should still work, but backwards. See? We get undefined because there is no 10th. Wait, yes there is. Is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get undefined. Interesting. I'm curious. And we never get to the 0. Okay. Yeah, while loops are not my favorite. So you can see you can either go up or you can go down, but all I'm doing is for every single iteration that I'm going through, let me just switch this back to how it was. It's way easier to understand. We're looping through the data based upon this conditional that we set right here, right? So the reason that we finally stop at 9 is because I is no longer less than 10 because it's 10 once we finally finish this loop, right? So top down, we're console logging, we're pushing these values out just so you guys can see them, but we're saying I is less than 10, so let's run this code, but then I gets incremented. So I is now equal to 1. We exit the code block, and then we re-evaluate this statement. So now we're evaluating 1 because we use this operator right here. So we incremented at the very end of the while loop, so now I is 1. So now we're saying, is 1 less than 10? Yes, that's true. It's true. So we enter the code block again. But then once we hit this, I is 1. So then it gets incremented again, and now it's 2. Come back up. Is 2 less than 10? True. Do it again. 3. Do it again. 4, 5, 6, 7, 8, 9, 10 is not less than 10, which is why the code finally stops executing at 9 and why we never see 10 with I, because that finally exits our while loop and we no longer need to run that code because we finally had this condition hit false. And that's why it's really important to keep in mind exactly what's going on in here, because whatever is going on in here, you need to manipulate in here in some way. Because if this is not being touched in any way in here, you're probably looking at an infinite loop. There needs to be some way for the while loop itself to essentially increment or change its finishing condition, because if it has no way to eventually reach its own finishing condition within the code block, then it's an infinite loop. It's 8:31. I apologize for going over. For loop, real quick. This is recorded, so I'll upload this for you guys. Essentially what we have going on here is a much safer loop. So with this loop, it's called a for loop. It's not a while loop, but it works in a very similar way underneath the hood. Here, it's much safer because we have the specific conditional set right away. So I'm saying right here, this is going to be my iterator. You'll see this always put as I. I is short for iterator because it's iterating over data. Iterating means to pass from one point to the next, to the next, to the next, iterating through data. That would be iteration. So that's why you'll see I used in for loops more often than not, because that's short for iterator. So our iterator is going to start at 0, and while 0 is less than the length of our array, which just so happens to be 10 elements, this will run. So this is the while loop part. This is the while loop part right here. While this is true, this middle statement, keep running the code, right? But the great part about for loops is you have to have this part at the end. So it's literally impossible to write an infinite loop with a for loop, because this is a needed part in order for this loop to run. If I erase this, it's going to error out. Oh, it's just going to infinite loop. Typically, your IDE would tell you that it would have red squigglies underneath this. Since we're in REPL, it doesn't do that. We'll get you guys working with IDEs once we start talking about HTML. For right now, since we're talking about basic JavaScript, we're just going to use REPL, but in your IDE, it would warn you that not inputting this I++ here would result in an infinite loop, so it would be immediately apparent to you that you need to fix that. Whereas with a while loop, the compiler doesn't necessarily understand exactly what's going on at a glance, so it won't protect you from an infinite loop if you're using a while loop. So for loops are much better for ensuring that you don't hit that infinite loop condition. But essentially we're doing the same thing. You can see we're console logging this array, we're going through. Let me run it again with the actual correct information. Does the exact same thing, it's just much safer. We have our same exit condition right here. The only difference is I had it so it was while I was greater than 10. This is 10 right here. The array length is 10. We have 10 units there. So this is literally the same in between these two right there. The only difference is I'm inputting the increments right at the end there, which makes it a lot easier to remember. And it also gives you more control over exactly what happens in the incrementation. But yeah, I apologize for going over. You're all excused if you want to go, if you have somewhere to be. But if you have any questions too, I'm going to stick around a little bit longer and I can answer those for you.